Welcome to Daily Papers.
Imagine a computer programmer that never needs to sleep, never gets tired, and can test millions of ideas in a day. Now, what if that programmer could not only write code, but could also learn to become a better programmer over time, all by itself?
That's exactly the idea behind a new paper we're looking at today. It's called CodeEvolve, an open-source evolutionary coding agent for algorithm discovery and optimization. It's all about using AI to automatically discover and improve computer programs through a process that looks a lot like evolution.
Right, it's a fascinating mix of two really powerful ideas. On one hand, you have large language models, or LLMs, and on the other, you have something called genetic algorithms. Let's break those down.
Okay, so LLMs are the technology behind things like ChatGPT. They are AI systems trained on massive amounts of text and code. You can think of them as incredibly smart assistants that can understand what you want and then write code to do it.
Exactly. They're amazing at generating new things. But how do you make sure the things they generate are actually good, or even getting better? That's where the second idea comes in, genetic algorithms.
This concept is directly inspired by Darwin's theory of evolution. Imagine you're trying to breed the fastest racehorse. You'd take your fastest male and female horses and have them produce offspring, hoping the next generation inherits their speed. Over many generations of only breeding the fastest of the fast, you'd eventually get incredibly quick horses.
Right, genetic algorithms do the exact same thing, but with code. You start with a population of different programs trying to solve a problem. You test them all to see how well they perform. That's their fitness.
Then you take the best performing programs, the fittest ones, and you breed them. You combine parts of them to create a new generation of offspring programs. You might also throw in a few random changes, which is like a genetic mutation.
And you just repeat that cycle over and over. Test, select the best, breed, repeat. Over thousands of generations, the code can evolve to become incredibly efficient and find solutions that a human programmer might never have thought of.
So this paper, CodeEvolve, brings these two worlds together. It uses a powerful LLM as the breeder. The LLM is smart enough not just to randomly mash code together, but to understand what makes two different solutions good and then intelligently combine their best features into a new, better solution.
Now, the team behind CodeEvolve wasn't the first to have this idea. They were inspired by a system from Google DeepMind called AlphaEvolve. But there's a huge difference. AlphaEvolve is closed source. Google published the results, but they didn't share the code. It's a black box.
And that's where CodeEvolve really shines. It's completely open source. The researchers have shared all their code and methods with the world. It means any researcher or even any curious hobbyist can download it, learn from it, and even help improve it. It's about making this cutting-edge science a community effort.
CodeEvolve also has a few clever tricks up its sleeve to make this evolutionary process work even better. One is called the island model.
It sounds tropical, but it's a really smart strategy. Instead of having one giant population of programs all evolving together, they create several smaller, separate populations. These are the islands. Each island evolves its own solutions independently.
This prevents the system from getting stuck on one single idea too early. It's like having different teams of engineers trying to solve the same problem in different ways. And then, every so often, the best solutions from each island are allowed to migrate to the other islands to share their good ideas.
This cross-pollination helps spread breakthroughs across the entire system and leads to more creative and robust solutions.
And there's another really cool feature they call inspiration-based crossover. In older genetic algorithms, breeding two pieces of code often meant literally cutting and pasting bits together, which usually just breaks the program.
But CodeEvolve does something much more elegant. When it wants to create a new program, it shows the LLM a handful of the currently best performing parent solutions and says, essentially, here are some great examples. Be inspired by them and create a new solution that combines their best logical patterns.
It's less about genetic splicing and more about conceptual blending.
The AI isn't just a breeder, it's an innovator that can learn from multiple sources of inspiration.
So, after all this, the big question is, does it actually work? Can this open source model compete with a project from a tech giant like Google?
Amazingly, yes. The researchers tested CodeEvolve on a set of really difficult mathematical and geometric problems. For instance, one problem is about finding the best way to pack a bunch of circles in a square to maximize the space they cover. It's a classic optimization challenge.
And the results were stunning. On several of these benchmark problems, CodeEvolve didn't just match the performance of Google's closed source AlphaEvolve, it actually found better solutions.
That's a huge achievement. It shows that with clever design and the principles of open collaboration, a smaller team can push the boundaries of what's possible and even outperform the giants in the field.
So what we're seeing here is a system that uses a process like natural selection to automatically get better at writing code and solving problems. It's a powerful tool for scientific discovery.
It's one thing to ask an AI to answer a question. It's another thing entirely to build an AI that can evolve on its own to become better at finding the answers. CodeEvolve is a fantastic, transparent step in that direction.
That's all for today's episode.
Thanks for listening to Daily Papers.